Okay, so computer programming, yeah. So you must be waiting for computer programming to be an interesting subject for you, isn't it?
Yeah, definitely. Yeah, I've done a little bit, but it was a long time ago. So yeah, it'd be good to learn something new.
Good. Computer based on hardware and software. Yeah.
Yeah.
Hardware, the physical components, and the software is a set of instruction computer programs, and those computer programs are basically written into a computer programming language basically.
Okay. Yeah.
Yeah. So any program set of instructions, yeah, being written in any programming language normally can be classified into low level language, mid, okay. So normally the programs initially when the computer was invented, or for example the any devices of, like, let's say computer, the calculator, or any any device, digital device, we call it a computer, yeah, because it can calculate or compute. So their internal program is written into the low level language, like in zeros and ones, because yeah, because it's the a kind of digital device, yeah, and digital device is basically based on 0 or 1, yeah, and 0 or 1 are on or off. Okay. And for example, if it is a memory, if we talk about memory, let's say 1 byte, yeah, then 1 byte is based on 8 bits, you remember?
Yeah.
And 8 bits and 1 bit means binary digit, yeah.
Yeah.
And binary means
ones and zeros.
Ones and zeros, yeah. So literally 1 bit can hold 2 values, yeah, either 0 or 1.
Okay. Yeah.
Okay. If it is a 2 bit, yeah, then how many values could be stored into a 2 bit?
It's not as simple as it sounds, is it? It's not going to be 4, is it?
It's 4, simply.
Okay.
Yeah.
I thought that was a trick question.
No, it has the this exponential 2. So 2 will be make like a 2 bit can store like a 4 values, like 0 and 0, okay.
Yeah.
0 and 1, 1 and 0, and 1 and 1, okay.
Yeah. Okay. Yeah.
Then if it is a 3 bits, yeah, 3 bits can hold 8 values.
Yep.
Okay. How, for example, 0 0 0, then 0 1 0, then the 1 0 0. These are 3. Then 1 1 0, then 0 1 1, then 0 1 0 1. So that would make like 8 combination if it is 3 bits. And if it is the 4 bits, then it would allow you to occupy, can let you 16 values to be stored, yeah.
Okay. Yeah.
Yeah. So by utilizing the number of bits, yeah, you basically write, you can, send the messages, via more number of combinations.
Yeah.
Like, 9-pin parallel port, 16-pin parallel port. Yeah, for example, if you have a cable, yeah, and normally, the printer cable that used to be, 25 pin, 9 pin. Do you remember those days?
Yeah, I remember all those. Yeah.
So depending on, the number of pins, yeah, means you, for example, if it is a 8, if any cable is, the 8, for example, based on the 8 ys, yeah, then 8 power to 2 would make you 256.
Okay. Yeah.
Okay.
Yeah.
So you can send like 256 commands over, 8 cable.
Okay. Yeah.
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 So within the computer, you might have heard, it's a 8-bit, the internal cache is, like a one. It used to be in older days, 128K.
Y-
Nowadays, you must have heard, it's a 3 MB cache.
Yeah.
Yeah. So the capability of the processor in order to carry an instruction, yeah, is getting higher and higher.
Yeah. Yeah.
Okay.
Absolutely.
Like the older operating systems used to be 32-bit.
Yeah.
Nowadays, they say that make it like a 40 or 64-bit operating system. You must have heard about it.
Yeah. That's it. That's what I use.
Yeah. So the more number of bits used in a machine, it means it is capable to carry more number of instructions.
Okay. Yeah.
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 So that's the basic concept behind the, hardware and its capability, and to let it program the, a code based on the length of the code.
Okay.
Okay.
Yeah.
So initially used to be the low level programming. They used to make the combination of zeros and ones, and that used to be called like a machine language.
Okay.
So if only the company or the device has to use the program, then probably they would be directly coding into the zeros and ones. Okay.
Okay. Yeah.
For example, uh, if there is any embedded device, yeah, and it has nothing to do with the user interface, then the machine would directly, write like, the machine language zeros and one is very faster, the fastest level of the language or computer instruction. Okay.
Okay. Yeah.
Then obviously it was very difficult to write any program into the machine language for normal programmers, because as the advancement came into the computer industry and the, wanted to let the users to design their own programs.
Okay. Yeah.
So the mid-level language came in, that used to be the assembly language.
Okay. Yeah.
So what used to be, it used to be a kind of high-level language and low-level language. High-level language is basically you write the computer program into human language.
Right. Okay. Yeah.
So assembly language was partially, high level, because there used to be commands like begin, and, and these words, as well as this programming language had direct access to the hardware as well.
Okay.
Okay, like there are certain registers into the, the certain locations into the processor, and, memory locations. It used to access, a kind of the low level language, and it was the generation when the programmers were given an option to write at low level, but using some little a bit layer of a high level language as well.
Okay.
Then how computer used to understand those mid-level language? The computer language uses a compiler basically.
Okay, yeah.
What does the compiler do? Compiler interprets the high level language code into the machine language directly.
Okay.
Yeah.
Yeah.
So the role of the compiler is to convert the high level or mid level code into the machine language. Okay. Then
Okay.
it was still difficult to write the programs. Yeah. And the another level of language was introduced, was the high level language. It used to be purely in human language.
Right, okay.
Right. So for example, you have Java today, you have a Python, you have a PHP. Okay. But the initial languages used to be like a C language, but not only the C, there used to be like a Fortran. Yeah.
Okay, yeah.
How many languages do you remember since those days?
What, going back to C?
Before C?
I don't remember any of that.
Okay. So for example, there used to be GW Basic, yeah, Fortran, COBOL, Verstar 4, yeah, and lots of languages were still used in those days, and those were written into high level language. And in order to write the programs into those languages, you needed a compiler.
Okay.
Yeah. So
Yeah.
compiler used to be like an independent compiler, or they used to provide IDE.
Okay, yeah. I've heard of that, yeah.
Yeah. You remember what is IDE?
It's like Visual Studio is an IDE. I can't remember what that stands for, but it's an environment where you write.
Visual Studio is the most advanced, interface. It's called Integration Development Environment.
Right. Okay. Yeah.
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 So integration development environment allowed to write the programs. Okay.
Yeah. Okay. Yeah.
So you need, if you want to write any high level program, then you need IDE. Okay. Integrated development environment. Yeah.
Yeah.
So for example, if we say C programming, then you would require the C IDE. Okay.
Okay. Yeah.
Integrated development environment. Okay.
Okay. Yeah. Is that quite a difficult language to learn?
No,
No.
not at all. So now, so you require IDE. For example, you C++, C, and if you are working on Fortran, then you need a compiler, and so you would need to know that what particular language uses, whether it uses the just compiler or IDE. For example, C gives you an IDE. Okay. The Fortran gives you a kind of compiler. Okay. The Pascal gives you an IDE. Okay. Java gives you a compiler. Yeah. And but if you use the NetBeans and other tools, then you still get the IDE. Visual Studio, you get IDE. Studio itself is an IDE. NetBeans, these are the platforms that give you then option to write, compile, edit, save, execute the programs, right?
Yeah. What about Python and PHP?
Yeah, Python and PHP, they are the web programs. Okay.
Okay. Yeah.
Then what you need a server in order to execute those scripts.
Right. Okay.
Yeah. So
Yeah.
obviously, if you would write the program into the HTML, for example, into the notepad, for example, you can
Yeah. Okay.
write. Yeah. You can store into the server, and the results would be displayed on the browser. Yeah.
Yeah. Okay.
But
Yeah.
there are still the editors which allow you to edit like a Dreamweaver. Have you tried the Dreamweaver?
Yeah. Yeah. I've seen that before. Yeah. Yeah.
Dreamweaver would allow you to create those web scripts, and the its compiler would reside on the server.
Okay.
Yeah. So those will be called as as a web programming languages.
Yeah. Okay.
Okay. So now, so that's clear that you need a compiler. Yeah. And again, there is the difference between the compiler and interpreter.
Okay.
Yeah. So compiler compiles the whole program, and interpreter, compiles line by line. Like there used to be different kind of programming languages, for example, GW Basic. Then if the program used to be, let's say, 50 lines of the code were fine, there was no any error, it still used to be working, because it used to work on the interpreter. Okay.
Yeah. Okay. Yeah.
Yeah. So that's fine. So now, based on these terminologies and idea, now we are here on the computer programming. Okay.
Okay.
Unit. So computer programming unit has a little jumping and unstructured assessment criteria and learning outcomes. Yeah. And but the history I have given to you is basically the from beginning to date. That's a,
Okay.
that's a kind of picture. We haven't entered into the computer programming yet. Yeah.
Okay. Yeah.
So, like unit 1 has 1 second. That, yeah. So number 1 learning outcome says talk about the API. Okay. Then talk about software development life cycle, talk about the language constructs. Yeah. So the language constructs like variables, constants, operators, loops, and conditional statements, they are fine at the moment. We can talk about the programming language. However, can you hear me?
Yeah, I can. Yeah. Sorry, I'm just making some notes.
Yeah. Okay.
That's fine. Yeah.
Then,
Yeah.
yeah. Then basically it needs to be given a sequence from the programming language constructs, then programming paradigms, yeah, then software development cycle, yeah, then API. Okay. And
Yeah.
then later on, the LO2 says designing a computer program using data models, the role of conceptual algorithms, and bit more, organized kind of, programs. But let us, start with a basic computer program concept, yeah, and then we will discuss the types of paradigms and how they use into the system development cycle, and then how it becomes the API. Do you know what is API?
It's Oh, it says it on there, doesn't it? I'm not going to say it. It links, doesn't it? Does it link one program to another?
Yeah, a kind of, yeah.
Yeah, or it adds a piece of functionality. Is that right?
To add a piece of, no, API is basically a kind of programming interface, a bridge, yeah,
Okay, yeah.
a bridge in order to communicate two platforms, two devices, yeah, and of different type,
Okay,
yeah.
yeah.
Application programming interface basically would work as a bridge, yeah, so that
Okay.
any data can travel between two different, maybe similar or heterogeneous platforms, devices, or anything.
Okay.
Okay, like that, for example, you don't need to, for example, if there are certain programs into the car, yeah, like
Okay.
functionality of let's say air conditioning. Okay,
Yeah.
sometimes you make it low, sometimes you make it high, sometimes you use the front, sometimes you use rear, yeah. And in digital cars, you normally that the screen of the car allows you to select it,
Okay.
yeah. So that's basically the API, yeah. And probably, for example, nowadays certain electrical appliances, yeah, they allow you to be connected with your mobile,
Yeah. Okay. Yeah.
yeah. For example, some people are selling like electronic, you know electric systems, for example the lighting, the heating control and other things. And they say, oh, this equipment can be connected with your iPhone via Wi-Fi or Bluetooth, and you can operate it from your bed.
Okay. Yeah.
Have you heard about those
Y-
things?
yeah. Yeah. You can have it so your lights, you can switch your lights on as well, can't you, through voice? And
Yeah,
yeah, I've not got all that sort of stuff, but yeah, I have heard of it.
yeah. So how that's done? Basically, that's done by allowing uh, the physical equipment, the electric equipment is being accessed through API. Yeah, you simply call that API, and no matter if it is the your mobile phone, however, the same program can be accessed with your desktop computer. Yeah, and same program can be accessed with any of the device that you want,
Okay.
provided you use any, you should be able to communicate with that device.
Okay.
So now, uh, the slides from the lecture would be a kind of more theoretical, but if you remember my explanation, yeah, then you can understand well those slides, yeah. And if you are not clear right now, then you can ask again and again, so that my understanding the definitions would be uh, sufficient as compared to reading hundreds of pages.
Okay. Yeah. Yeah.
So ask me any question if you don't understand, and I would repeat, and then we'll move forward, yeah.
Yeah, that's fine. Yeah. Yeah.
now now for example, if your brain is computer, okay, and i'm asking you to aid I'm asking you to do some calculation for two numbers, okay. Number one is 5, okay,
Yeah.
and number two is 3.
Yeah.
What would be the addition?
8.
8. What would be the subtraction?
That would be 3.
Okay. What would be the multiplication?
Would that be? I'm not sure what that would be.
5 to the 3 is 15.
Okay.
Yeah. And if I say you, for example, so I would be telling you every time like different numbers, and you remember additional 1 that you need to add every time in the answer.
Okay.
So what was the first number?
What the first number that you gave me?
Yeah.
It was 8.
No, it was 5, and the second number was 3.
Ah, right. Yeah. Okay. Yeah. Yeah. Okay. Yeah.
So if I ask you to give me the addition,
That was 3, wasn't it?
no. The first number is 5, the second number is 3. Then what would be the addition?
It was 8.
Yeah, it's 8. And I gave you one number like a 1. You need to tell me, you add that number in the end and tell me the answer. What would be that?
That's going to be 9, isn't it?
Yeah. Okay, good. And if I say you multiply and add that number,
What number 1?
no, multiply first value with the second value and add the fixed number, then what would be the result?
Is that 15?
Plus 1.
Yeah, 16.
Okay. Now I'm changing the numbers now. Okay. The first number is 2 and the second number is 2 as well.
Okay.
Yeah. So what would be the total output?
The output that's going to be 4.
And you add something. What you would add?
You would add 1.
Yeah. How much will be total?
5.
And if I ask you to do the operation of multiplication, then
That's going to be 1 times 5. Is that right?
No. I'm just asking you to do multiplication in 2 numbers and then add that number.
Which number? You say add that number. Which number? So we've got 1, right?
Yeah.
And I've taken 1 and I've added it to 5.
No.
Which is 6.
No. You don't. We are only doing only one calculation at one time.
Right. Okay.
So the one fixed number is 1. Okay. Whatever the operation you do, you have to add that number in the operation and give me the answer in the final.
I don't get this. I don't get where this is going.
No problem. The first number is 2. The second number is 2 as well. Okay.
Right. Okay.
And the fixed number is 1. Okay.
Okay. Yeah.
Yeah. Then every time what operation I'm asking you to do the addition, and the fixed number you have to do is add that number in any operation, whatever the operation you do, but you have to add it and tell me the answer.
So can you write this on the screen, because I don't actually get this. I don't
want to write, basically. That's the reason behind.
Sorry?
Sorry, I don't want to write this. That's the reason behind, because I want your brain to run like a computer.
Oh, right. Okay.
Yeah. Simply, I'm repeating. Let's take it easy. Okay. There is a one number. Yeah. There are 2 numbers that I would give you the values. Okay.
Yeah. Okay. Yeah.
Values can be changing. If I would, ask you to change, then you have to remember those. Okay.
Right. Okay. Yeah.
And there is one fixed number, right? Are you writing on the pen?
No, I'm not. No.
No. Okay. So there is a game of 3 numbers.
I'm trying to do this from memory. So you're you're saying it, and I'm trying to remember
There is
it.
a game of 3 numbers. Yeah.
Yeah.
One number is fixed and 2 numbers are changing. Yeah. So every time I give you the numbers, I would tell you the operation. You need to do the operation on the the numbers I will give you, and then whatever the answer will be, you need to add the fixed number and then tell me the answer.
What's when you say the fixed number? What do you mean by that?
I mean fixed value.
What? Yeah, but what is that? Is that when you say fixed value? Is that the answer to?
For example, if I gave you 1, yeah,
Yeah.
so you have to remember that it's a fixed value that I would, you need to add a grace every time.
So the first number that you give me is the fixed number, yeah?
No, no. Let's say the third number is fixed.
How do I know which number's the fixed number?
I'm telling you.
Because you give me 2 numbers, so you gave me like what was it? Was it 3 and 5?
1 second.
And then you said what's the answer to that? And then you said what's the fixed number?
Okay,
But I don't know which the fixed number.
1 second, yeah. Now you create, a place in your mind, yeah. A fixed number is always 1. It's on the one corner of your brain.
Right. Okay.
Its value is 1.
Right.
Right? That's stored. That's not going to change. Every time when I say that when you do the calculation on another 2 numbers, yeah, then what you need to do, whatever the result you get from those 2 numbers, you add that fixed number and tell me the answer.
Right. I've got it now. Okay.
Okay.
So
now,
essentially a fixed. So what you're saying, a fixed number
yeah,
is 1.
yeah,
Right. Okay.
yeah, and the 2 changing numbers in previous example, the first one was 5 and the second one was 3. Yeah.
Okay. Yeah. Yeah.
Then I gave you another example that the first one is 2 and the second one is also 2.
Okay. Yeah.
Now if I ask you to do the addition and do the addition of fixed number, then what would be the answer?
So sorry. What was the numbers again? It was 2 and sorry.
The first number is 2. The second number is also 2.
Right. Okay. Yeah. So that's 4.
Yeah.
Plus 1 is going to be 5.
That's right.
Yeah.
And if I ask you to do the subtraction,
that's going to take it back to 4.
I don't know. You do the subtraction on
Yeah,
these
4. That's going to take it back to 4.
No. How 4?
So the first number is 2.
Yeah.
And then the second number was 3. Yeah.
No, not 3. I didn't say 3. I'm saying
you
2.
said 2. Yeah, you said 2, didn't you? Yeah. Okay. So that brings it to 4.
No,
So
you are doing the subtraction,
So 2.
Yeah.
Right. So 2 take away 2 is 2.
Yeah.
Then you add the 1, which makes it 3.
What is subtraction?
Take away.
If you would take 2 away from 2, then how much would be left?
2.
No.
No, 0, isn't it? Yeah, 0.
0. Come on. Yeah. Then what would be the answer?
0.
Total answer?
1.
1. And if I ask you to do multiplication and then operation?
What on those same numbers?
Yeah.
So that's going to be 2 take away 2.
Not take away. I'm asking you the multiplication.
Hang on, times. So it's going to be times. So that's going to be 4.
Then
Add the 1. That's 5.
5. Yeah. Now, if I'm asking you to make it 3 and 3, the first number is 3 and the second number is 3. Yeah. Now forget about the 2. Now I'm giving you the values for the only 2 numbers. Yeah.
Okay. Yeah. So 3 and am I doing multiplication again?
No, addition.
Right. Okay. So that's 6.
Give me the final.
7.
Okay, 7. And if I give you the number 4 and 4 and do the addition.
9.
Sure.
Yeah.
So did you realize that the fixed number is stored in your memory forever,
Yeah.
and the 2 numbers are changing.
Yeah. I get that now. So the fixed number is always 1.
Yeah.
Which never changes.
Yeah.
That's right. Yeah. Okay.
And now can you read this and see something what we have done in your brain?
Yeah. See.
Sorry, I used your too much brain today.
Yeah. I'm just trying to work out that middle bit. What that middle bit means.
Now see.
The C. Yeah. The rest of it I get. I'm just trying to work out what that means. The consist C. And then the end bit is A and B. Yeah, I kind of get that.
You got it?
Yeah, because it's at the bottom there. I can see the C as well.
So
A. So basically, whatever the value of A and B is, you're taking that and then you're adding the value of adding the value of C.
now, are you clear about all the bits? I need to explain to you.
Okay.
No, you tried. Are you clear? Let me. Which part you want me to explain?
It's just that consist C. I'm not entirely sure where that fits in.
About what?
Where does I don't really know what that means. I get the other
About
bits.
what?
The consist C, which is the third line down.
This.
Yeah, that bit there.
Okay, now let me explain to you. So I told you to do some program or game, whatsoever you say. Okay, your brain, I made you ready to do something. Okay, I made you, I asked you to do something, you became ready, isn't it?
Okay, yeah.
Are you ready now? For example, you said maybe you need few seconds to get ready if I give you the new numbers again. Okay,
Yeah.
so every program needs start. Okay,
Yeah.
I told you that I would give you, for example, create a memory space in your brain that's fixed.
Okay. Yeah. Yeah.
Yeah.
Okay. Yeah. Yeah.
So in
Yeah.
computer terminology, when you write, let's say const, that's a constant, and its type is integer.
Okay.
Yeah. So you know the difference between the integer and real numbers.
Yeah.
Like integer is, you know, the without fraction, and the real numbers are, you know, they come with points. Okay.
Yeah.
So definitely, if I would have asked you to, you know the first number is 1.5 and the other number is 3.5, then your brain must have been used little bit more.
Yeah.
Okay. So when I said you are getting, you are expecting the numbers, they are integers, so that would be like a 5, 6, 7. So you're expecting a constant number, that would be integer.
Right. Okay. Yeah.
Yeah, that would be C, for example.
Yeah. Okay. Yeah.
In that condition, it was 1.
Yeah. Okay.
Then I told you there would be another two number A and B. Their type would be integer and integer same.
Yeah.
Okay. And I told you that what you will be doing, you would be telling me the total operation, that would be the answer.
Right. Okay.
Yeah. Obviously, you at the time of giving an answer, but still you had some space and space to do some calculation and store into your brain and tell me via your, you know, tongue,
Yeah.
isn't it? Obviously, you were taking it from your brain, isn't it?
Yeah.
That I was asking you to tell me at the end, isn't it?
Yeah.
Yeah. So I told you put the C equal to 1 forever.
Yeah.
Forever means as a you know a fixed. Yeah.
Yeah.
So in terminology, that is called the constant.
Right. Okay. Yeah.
And A and B were the variables.
Right. Okay. Yeah.
Yeah. And the answer, how you were expecting the answer, you were expecting the answer first, the addition or subtraction or multiplication between A and B.
Yeah.
And remember, we have used a bracket here.
Okay.
Yeah. So the priority was you need to add or do the calculation between those two numbers which are variables. Yeah.
Yeah.
And then add the number C.
Okay. So yeah. Okay.
You got it?
Yeah, I've got that now. Yeah.
So the kind of arithmetic expression is evaluated. The precedence is given by using the brackets. So it would never be the case that, for example, B would have been added to C, but no. Whatever the answer of addition is, you would have added the constant into that value and then you assign into the answer.
Okay.
Yeah.
Yeah.
Print answer. Yeah.
Yeah. What is that? What language is that that you're using there?
I haven't used any specific language. I have written this a kind of general code that's called a pseudo code.
Okay.
Yeah,
Yeah.
like a pseudo code is basically the human understandable code. Yeah, and in order just to explain to you, to give you the language constructs of a programming language, that you used variables, a kind of a and b. Yeah, you use the constants. Yeah, a constant variable as well. You use the operator as well.
Okay. Yeah.
So if I ask you to say, give me the answer, for example, how much was the answer of addition when the values are 2 and 2?
It was 4, wasn't it?
Yeah, and how much was the answer?
5.
Okay, how much was the answer?
It was it was 2.
No.
Sorry.
How much was the total answer?
It was 2 plus 2.
Yeah, the total answer was, yeah,
5.
5. Can you tell me again how much was the answer?
5.
Sorry. Can you tell me how much was the answer?
It was 4.
5. I'm not asking you to change anything. I'm just asking you, can you tell me how much was the answer?
6.
No.
7.
If the one variable is, the 2, another variable is 2, and do the addition,
It's 4, isn't it? 2 plus 2 is 4.
then total, then after adding the constant,
Plus 1.
yeah,
5.
5. Okay. Can you tell again how much was the answer?
5.
Can you tell me one more time how much was the answer?
5.
Can you tell me one again how
4.
much was the
4.
answer?
4.
No,
Sorry.
5.
2.
I'm just asking you to repeat it, the answer, the same answer.
But what? 5.
Yeah. Can you tell me one more time the answer?
5.
Yeah, 5. We are basically, I'm asking you to give me the answer into a loop.
Do you want me to tell you again?
That's when I ask you to repeat anything. I'm not asking you to change the answer, but I'm asking you to give me the answer, the same answer again and again.
Yeah. Okay.
Yeah. So that's basically the loops.
Okay.
Sorry, I made you to tell me the answer again and again, but when the computer is being asked to give the answer again and again, yeah, it has to repeat the same thing, exactly every time.
Yeah. Okay. So
Yeah.
so that does that impact the performance then? Does it? Because if it has to keep going over and over and over and over and over again, that's going to slow things down.
No matter, but you need some time. For example, if this is the screen, yeah, you can see the screen. A screen is likely what I believe, for example, 8.27 into 11.69h. 8.27 is the height and 11.69 in inches.
Okay. Yeah.
So what do you think that in all sudden this screen, is being developed in front of you? No. What happens, it starts with, giving you a kind of, the dimension is like, let's say 1 1 1 2 1 3 1 4, like a first row first column, first row second column, first row third column, in this
Okay.
way.
Yeah.
Then second row first column, second row third column, second row fourth column, blah blah blah, like it would reach to the end. Yeah. So it happens, by using the loops.
Okay.
When you are looking at a particular, when, for example, this screen is in front of you, then it is continuously looping in front of you.
Right. Okay. Yeah.
Yeah. So
Yeah.
the loops are used whenever you want to iterate the
Okay.
instructions or set of instructions. You need to use the loop.
Okay. All right.
Yeah.
Yeah. Sorry, I'm just making notes a minute. I'm just gonna make another note a minute. See. Okay. Yeah.
So whenever you want to iterate or repeat an instruction or set of instructions, you need to use the loop constructs.
Okay.
Yeah.
Yeah.
So there are different types of the loops. Like I have written for I is equal to 1 to 5. It means I would be repeated 5 times.
Okay. Yeah.
Okay. So this print would carried out for 5 times. 1, 2, 3, 4, 5.
Okay. Yeah.
Okay.
Yeah.
So the repetition is carried out by loops in programming. There are different types of the loops like a for loop, while loop, do while loop.
Uh, is for each? Is that a loop?
Like, they say for each means this bracket and this bracket, and anything within these bracket would be repeated that number of times,
Okay.
right? While, let's say while, and then you give a kind of condition, then
So okay. Yeah.
ABC. So condition is while, let's say I less than 5. So basically what happens is not always, the quantity of loop is not known,
Right. Okay. Yeah.
because for loop is used when you know the quantity, but you don't know the quantity, and the repetition of the loop is depending on certain condition.
Okay.
Then you use the while loop.
Yeah.
Okay. And what happens in the while loop, sometimes the condition can be false in the beginning, and the loop body will not be executed at all,
Okay.
right?
Yeah.
And when it is a do while, then condition would be checked after first execution.
Okay.
Yeah. So at least one time the loop would be executed.
Yeah.
Okay. Is it clear?
Yeah. Yeah. That's clear. Yeah. I'm just making some more notes.
Okay. Then next is the conditional statements.
Right. Okay.
Yeah. Conditional statements are the selection of statements. Conditional statement is the selection of statement based on a condition.
Okay.
So selection of conditions based on a condition. For example, if A is greater than B, then A minus B, else B minus A.
Okay.
So the conditional statements are executed based on the condition.
Right. Okay.
So in condition can be, the can be an alternative condition, like alternative is, for example, if A is greater than B, then you do this, otherwise you do this.
Okay. Yeah.
Yeah? Or
Yeah.
the condition can be a kind of selection out of choices. For example, switch. Switch is like, when you pass, let's say, condition.
Okay.
If condition 1, if you would pass 1 into this, into the condition, then condition 1 would be executed somewhere here. Condition 2 would be executed somewhere here. Yeah. Condition 3 would be executed somewhere here. So whichever the condition would be, yeah, passed into this switch, the only particular statement would be executed.
Okay. Yeah.
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 So you have, kind of variety, that you can use the variables, you can use the constants, you can use the operators. Yeah. Operators like we use, the plus minus. Yeah, they are called the arithmetic operators.
Okay. Yeah.
But when I say A greater than B, yeah, these are called the logical operators.
Right. Okay. Yeah. I'm just gonna take a screenshot a minute
Yeah,
of what you got there, 'cause I'll probably do some notes
yeah,
afterwards. Just need to save that one. Okay, yeah, I've got that now.
yeah. And
Thanks.
so according to the introduction to these statements, you are clear now what are the conditional statements, loops, operators, constants, and variables. Yeah.
Yep, I've got all that now. I've got notes as well, because the problem I find with this course that I'm finding as time's going on is when I've done I do the class
Yeah.
and I fully understand it all, which is great. But then when I come to do the assignment,
Yeah.
it could be a while before I do it. I've forgotten some of the things, so I have to go back over it again.
Yeah,
So
no worries. You can note down the on the notes, and these things you basically need to be memorized. And the things I'm telling you, uh, those have been studied about, let's say, 19 years ago.
Yeah, yeah. So
So
a
yeah,
lot of this stuff, when I'm sure when I come, what I am finding though is that when I come to do the assignment, when I look back over the notes and
yeah,
the PowerPoint presentation, it all comes back to me.
yeah, definitely, yeah.
Yeah,
So
it's just trying to re-trigger the memory for it all to come back, and then I remember it then.
yeah, and maybe if you can teach someone the programming the today's session, yeah, you would remember more.
Yeah, yeah, that's not a bad
Maybe you
idea.
find someone, maybe your wife and or anyone else, you tell them I'm going to teach you, the
Yeah,
programming.
I'm not
So
I'm not sure about my wife, but yeah.
maybe you could offer her a dinner and possibly she could, listen to you. That's possibility, and you will have a good chance to remember these things forever.
Yeah, yeah, I'll give it a go. I'll let you know how it gets on.
And possibly, and there's more, possibility that when she would ask you lots of questions, yeah, and she would disagree, and then you will have a more and more, sharper memory to remember it with a, kind of incidences that how you try to remember and understand this.
Yeah, yeah,
Yeah.
yeah,
So that's it. And there's little more, definition regarding, the procedural programming and functional programming and object-oriented programming. So, like today, we discussed the difference between the low-level language, high-level language, and the low-level, mid-level, and high-level language. Then the procedural programming, functional programming, they are basically the types of high-level programming languages. Yeah, that we will
okay.
discuss, in the next lecture. That
Yeah, okay,
how
yeah.
they make, the procedural, functional, and these things. And obviously, I had to, complete this 26 slides, but the things that I have, given you verbally in the notepad all covers even more than these slides into this, one notepad. Yeah.
Yeah, okay.
Okay. So I see you, on Wednesday, and I hope you should be able to, remember these things. And probably, once we will have uh, these things, theoretically discussed, and I would give you a kind of demonstration of a programming language as well. Yeah.
Yeah, okay.
Okay.
Um, just one other thing. Did you say that you've got some more feedback for me on the information systems assignment?
No, to be honest, I haven't, sent my feedback to the IV yet. Yeah, but let me do it, tonight, and you would get the final feedback, very soon. Yeah.
Yeah, okay. Because
Although, yeah,
yeah, sorry, because that'll be 2 assignments that I've done then, won't it? Or will that be 3?
I do, I think, because you have sent the second version of the computer systems and the second version of information systems. Yeah.
Yeah, okay.
So yeah, they are literally, passed because the assessment criteria was already made. Yeah.
Yeah, okay, great.
Only, yeah, only you had you were given a kind of, constructive feedback so that you can, minorly change it and resubmit it. Yeah.
Yeah, okay. Okay, all right, I'll speak to you on Wednesday. Thanks.
Yeah, and most welcome. And you can try your best for the third assignment, and so that your three of them would have been done as soon as possible, and you can do a few more, and as soon as you would be, you would complete, and it's good.
Yeah, yeah, because I've already done part of the systems analysis one.
That's good. Yeah,
So I've got I'm ahead on that one as well. So I'm gonna try by the end of this year to
yeah,
get the database one in,
yeah,
and the systems analysis. I'm not sure when I'll get that in. It depends how much time I've got.
yeah. That's
'Cause
fine. Yeah, you try your
yeah,
best, and you will be sent the feedback. And in the meantime, you get the feedback and you can always carry out your work on the other assignments. Yeah.
Yeah. Okay. Yeah. All right. I'll speak to you on Wednesday.
All right. That's fine. Thank you. Bye.
Okay.
Bye.
Thanks. Bye.